Focus on inscribed angles. And so an inscribed angle is not the same as a central angle. So inscribed means that it touches the outside of a circle. So if I have a circle like this, okay, and this is the center, the angle, so this is the center of the circle, and this is called the central angle. So we knew that, and then this would be what we call an arc. The measurement from here to here, and that could be in degrees, okay? But now we can also have what we call an inscribed angle, and the inscribed angle is the vertex of the angle is on the circle itself. It's on the edge of the circle. Okay? And so what we have here is, if I were to label this, so let's label this A, let's label this B, and let's label this C. Okay? Actually, let's change these around so it matches the book exactly. So this would be A, this would be B, this would be C. So now, if I'm referring to the relationship of those, and then the center, we'll call the center P. So we'll call that P. So I would say that the angle APC is the central angle. Angle ABC is inscribed. And then there is a relationship between the two. So I could say that the measure of the arc AC is equal to the measure of angle APC, whoops, and that's equal to two times the measure of angle ABC. Now it's kind of hard to tell because my picture that I drew is not quite perfect. It's not, I freehanded it. It's not perfect to scale, but as you can see here, that this angle here, if I were to give that a number, this angle here would be about half that angle. Okay? And the reason for that is that the distance of the arc, or the distance of the angle, is twice as far. In other words, this one, because it's on the circle, in order to make the arc, the radius goes from here to here. But for this one to make the arc, the radius is half the distance for the sweeping motion. Okay? So the diameter is 2 times the radius, and that's why we have to have half the angle. So there's a couple ways that you could write that, but let's just look at example number 1 and put some numbers in and see if there's a relationship, okay, and see how we determine what that means. So for example number 1, I have a circle, a perfectly drawn circle that goes through here and kind of does one of these deals, where we'll call this Q, R, P, T, oops, T, and S. And we're told that this length from here to here is 48 degrees. God bless me. And this length here is 50 degrees, or this measure of this angle here is 50 degrees. So if I were to write that, I would say that the measure of the arc R to S is equal to 48 degrees, and that the measure of the angle QRT is equal to 50 degrees. And what they want us to find is, what is the measure of angle RTS? That's one thing that we have to find. And the other thing that they want us to find is, what is the measure of the arc from Q to R? Okay? So let's do this first one, RTS. Okay, so that would be 1/2 of what this is. In other words, the measure of RTS is 1/2 times the corresponding arc. Well, that was pretty easy. And that's based on this relationship. If we divide both sides by 2, we'll get this relationship. Okay? So then the measure of QR from here to here, that's a little tricky because I'm not quite sure I know what that angle is. Usually we've been using the measurements of well, anyways, we can figure it out. So what I know though is that I was thinking of the best way to word that. I know that from here to here is double this value, so I'm just going to label that as 100. Okay. I know that the central angle has to add up to 180 because this is a semicircle. In other words, what I'm looking at is I got this thing here, okay, and I know that this part right here, we'll say that this is T, this is P, and this is R, and then this is Q. I know that this is 100 degrees, but because it's a semicircle, it has to add up to 180 degrees. So what I'm going to do is I'm going to say that the measure of, well, you just do it like this. You're just going to say 180 because it's a semicircle minus the measure of QT. In other words, I know that this is 100 degrees, and find the measure of QR. I need to make sure that that adds up to 180. So what I could do is say 180 minus 100. 180 minus 100 equals 80 degrees. And that's it. We're done. Now this one is tricky because it's an application of this process up here, but then we also have to use our prior knowledge. We have to know that because TR is a diameter of the circle and it goes through the center P, that it creates a semicircle, 1/2 of a circle, so then the arc measurement has to be 180, right? Because the measure of the central angle, the measure of a straight line, is 180 degrees.